Okay, we're ready. So, while Benjamin mainly works with JavaScript, he's also interested in systems programming. And now, thanks to WebAssembly, he's able to experience the expressiveness of assembly code coupled with the efficiency of JavaScript. And he wrote a Game Boy emulator, which, if I understood correctly, works best on Internet Explorer 6. Is this correct? Well, he will tell us. The talk is Zig, a great fit for emulators. And so, Benjamin, the stream is yours.
Thank you for the introduction and thank you for arranging all of this. This is awesome. And yeah, so I wrote an emulator. It's a Game Boy emulator and it runs on in the browser. And you can access it at this URL here. And I'm just going to show it off while it demos Super Mario Brothers while I go through this talk. And just a quick overview of my emulator called Fun Dude. It's a pun on Game Boy if you because naming things is hard. And it's basically my first emulator ever that I wrote in Zig, and it is running in WebAssembly. And it's actually also my first Zig program that I've ever really written, and it's my first WebAssembly. So this is kind of a series of firsts for me. And I've been programming for about like 10, 15 to 12 years now. And I've originally started with C. So this is actually my emulator that I ported over from C into Zig. So C was my previous systems level programming of language of choice. And it sort of has a I have a fondness in my heart, but I also recognize that there are many problems. And part of the reason I'm learning Zig is that I want to see if it solves most of those problems. And I like to think that it does. And just a quick overview of Zig and what it does. It is a lot more modern language. So it just comes with a lot more better designs that we have learned in the past 50 years, because C is a very old language at this point. And these are also features in other modern languages that most of them also solve these. So I'm not going to get into these too much in detail, but all of these help tremendously in working on the emulator. So what I will do is go over some of the more nuanced things that I find that Zig actually helps really well in terms of mapping these low-level programming into something like an emulator. And the first thing is that Zig prefers explicitness. And whenever there's an ambiguous case, the usual default to Zig is to compile error or to runtime error, whichever makes the most sense. And a good example here are ambiguous casts. And this is a version of my of a signed ad that I previously wrote in C. And in C, we have a concept that we can cast numbers around. And one of the many downsides of C is that even though you have quite a few different number types, they all sort of cast into each other, and the rules are really complicated. And it's not actually obvious what's happening here. Like what I want to do is I want to convert B. Right now it's an unsigned integer. I want to convert it to a signed integer. So I actually have an explicit conversion here. So anything over 127 is actually a negative number in signed in format. It's 2's complement. And I need to go ahead and convert that to a subtraction. And then I need to go and add it in with the original value. And I actually don't know what's going on here. I am looking back at the code and I realize that this has two different ways of doing implicit casting as well as undefined behavior at the very end down here. Actually, I think two undefined behaviors. The add is undefined, and then the return is also undefined. So there's a lot of bad things going on. And in C, I actually didn't know any of this was happening. I just spat this out because it seemed like it worked. And it does work in my compiler, but that doesn't mean that it's good code. And when I converted it to Zig, Zig actually forced me to go fix all the problems. And at first, it was really annoying because there were so many problems with the code. It was just very hidden. And in Zig, what ended up happening is that my final attempt, I actually implemented in a way that makes a lot more, is a lot clearer, because you actually see what I'm trying to do here. I just convert the B into a signed integer, and then I convert A into a signed integer, and the only implicit cast here is converting this 8-bit integer into a 16-bit integer, and that's actually very well defined. So a -1 from an 8-bit integer will convert to a -1 in 16-bit. There's no problem there, and I don't even want to think about that, and I don't have to because Zig automatically casts that for me. All the other casts are explicit and for very good reasons, and I think that this is just a better representation of the problem, because Zig gives me the capability of representing this, and it also like prevents a lot of weird issues that were coming from the C side because of the explicitness. And even though I had my reservations of the explicitness, I've really come around to enjoying how the language forces you to just write better code. And another thing that Zig does really well is exposing compiler intrinsics. And let's take a look at the example code first. This was in C. This is also valid Zig syntax, and the only thing I'm not really showing is that CMP is a packed struct. So what this means is that each of these fields is actually 1 bit wide. So what I'm doing here is that I'm trying to find the first bit that's active, and once I detect whichever bit that is, then I will jump to this address. And this is an interrupt handler. So these interrupts are ordered. And if you have a vblank interrupt and a joypad interrupt active at the same time, the vblank will fire first, and this one will just disappear until like whenever the next interrupt cycle handles. And this works. There's nothing wrong with this code. It's just very slow. This actually runs every cycle on the Game Boy. And because of that, this actually is 5 branches with 2 or 3 instructions each, and that really is a performance hog. And I benchmarked this, and I realized that this was actually taking up like 15-20% of my CPU cycle, which is actually not quite a bit for something so small. So in Zig, what I'm able to do is actually convert this into a much simpler program. And this is purely because of how Zig exposes compiler intrinsics. And compiler intrinsics are a low-level detail of a compiler. And C actually has this, but C compiler intrinsics are not built into the language. It's built into the compiler. And I actually didn't know about these things before I started working with Zig. So in terms of what all of this means is that there are two intrinsics that I'm actually using bitcast, which is sort of available in C but not really, and then CTZ, which is definitely available in Clang and GCC, and it depends on your compiler. And CTZ does count terminating zeros, so this is actually going to count the number of zeros that are happening starting from the least significant bit. So this actually maps directly to here, where vblank is the least significant bit, and joypad is, I think, number 5. So I just go and count the number of bits, and then I convert that to a straight math equation, and there's only 1 branch. And this, I think, is around 4 cycles and 1 branch, which is far easier for the compiler or for the CPU to execute. And this improved the performance quite a bit. And this is because I am able to use the CTZ. And again, this is available in C. It's just not very obvious. And if you look at standard documentation, you won't find this because it's not a part of the C standard. It's a part of the compilers. And I actually didn't know that that was a thing. Whereas in Zig, we actually expose a lot of these compiler intrinsics into the reference documentation. And I believe that most of these will exist going forward in the Zig compiler. So this is a lot more readily available. And I think that because Zig is a more modern language, it is able to expose a lot of these things. And C was written in the 70s, and it was designed to run on a PDP-7, which is an ancient piece of architecture. And there's a few references online that talk about how like modern C doesn't actually map to a modern assembly anymore. And one of the reasons is that it doesn't actually expose a lot of these new things that CPUs have. And lastly, this is going to be a bit more in depth, but Zig enables more control of bytes. And I'm just going to give a quick overview of how the Game Boy works internally. And when the Game Boy has 8 8-bit registers and around 6-ish 16-bit registers. And this looks pretty familiar if you are familiar with the x86 architecture, because x86 is built off of the Intel 8080, of which Game Boy also goes off the Intel 8080. And the processor is an 8-bit logical processor with a 16-bit memory bus. And that means that the processor needs to address both 8 bits for doing math and 16 bits for doing memory manipulation. And how that works in the Game Boy is that it creates these registers, these 8-bit registers, A, B, C, D, H, F, and L. And I went all over the place with that order, but you can also refer to these registers as 16-bit registers, and that would be the AF register, the BC register, DE, and HL. They're literally just 2 registers glued together. And those actually occupy the same space in memory, which means that in order to represent that in an emulator, we have to somehow represent both B, C, and BC all together in one memory space. And how this is traditionally done in a C-like language is that people will recommend you create just 16-bit registers. So like the AAF register is a 16-bit value, and BC, and on and on. And this works, but you get into the problem of how do I access the A register? Well, you need to do some bit shifts. So you need to you need to mask the AF register and shift it right by 8 bits. And that's kind of annoying. And then when you set it, you also have to do the same, and that's really easy to get wrong. So you end up creating these getters and setters. And the F register is actually special because it's the flag register. It has 4-bit flags that are relevant. So in order to get at those, you need more getters and setters and on and on. And this is code that I really don't want to write. This is the reason why I like using a good programming language, is that I should be able to represent this idea in the language itself, and this would really annoy me. But this is sort of the recommended approach, because this is actually the only way you can do this reasonably within the C standard guidelines. This is not what I did my first pass in C. What I did was I actually used a union, and I used a union with a bunch of structs with a bunch of bit fields. And in a union, you share memory space. So the AF field actually shares the same space as this bottom field right here, which is a separate A and F. And F is broken down into bit flags, and we have an additional padding in order to align it properly. And this works, sort of. Now, there are many problems with it. If you've noticed, I created this int4. That's because I didn't really want to get into the details of C. C doesn't have an int4 type. That does not exist. You have to use bit flags for that. But more importantly, none of these fields are actually going to align properly. And that's because in C, the compiler is allowed to pad your fields however it wants to. And in order to turn off padding, you need to use compiler extensions, which make it not as portable as it should be. So GCC and Clang has a way of telling these attributes to be packed, but that's, again, not a part of the spec. So in order for this to work, I have to sacrifice portability, which I'm fine with. But again, like, some people are very much against using this type of this style, and a lot of recommendation says you shouldn't use bit fields. The other more sinister problem is that most people wouldn't notice this, but unions are actually not spec'd out to do this. Like, the only thing that a union is allowed to do is that they share bytes, and if you use one field, that field is guaranteed to have the same memory space. If you try to cross between fields, so if I stick something in the AF register or the AF field here, and I try to access A, that's actually undefined behavior by the C spec. Now, I don't know of any compiler that makes it do anything other than accessing the correct memory space, but technically it's against spec. So again, there's a lot of undefined behavior going on that it's not really apparent that it exists. And lastly, this is more of an internal problem, but like architecturally, there's a problem with doing this. Now, I can refer to these registers as either the field name, which is AF, A and F, or I can refer to them as a pointer value. So if I try to save which register I'm using, I have to use a pointer into AF. And both of those work, and neither of them are optimal because, first off, pointers cannot be serialized properly. So if I'm trying to dump the CPU and I'm trying to dump a state of execution, I can't actually dump pointers, because as soon as I try to unserialize that, the pointer values are just totally wrong. It also gets in more bigger problems when I'm trying to do a disassembly. And if I just have a pointer, I have to look up what that pointer means, and then I have to do an offset calculation compared to the struct, which again is more undefined behavior. So what I really wanted to do is I want to standardize it by offset. So if I could refer to all of these by offset, then everything would work out. So here, I written out what I really wanted to do, and I have a list, an array of 16-bit registers, array of 8-bit registers, and then the flag here that just sits at the bottom. And this would work. Like AF would be an offset of 0, BC would be an offset of 1, which will actually be 2 bytes here, because this is a 16-bit array. And that would definitely work. And similarly, it would work down here because, and these are backwards because of Little Indian. But that's okay. That's an internal detail that we can just ignore for now. And all this works, except the problem in C now is that if you do this by arrays, you're just going to get numbers out. And in order for us to work with them, we're going to have to just work with ints. And it's really easy for me to accidentally pass 0, or if I pass a 0 from this array into this array, and that accidentally crossing these registers is a very common problem because I have 256 instructions. It's very easy for me to make a typo, call it B instead of BC or something, and all of a sudden I just have garbage coming out, and it's not really obvious why. And that's because enums are just ints in C. And how I would solve that in Zig is actually really easy. I just use an enum array. And this solution didn't actually come to me until I started using Zig, because enum arrays were a very easy concept. This is doing a little bit of generics and comp time, but because enum arrays don't exist at the language itself, but that's okay. And this will basically make it almost impossible for me to cross these values because everything's accessible by enums now instead of by numbers. So if I try to stick an F into this 16-bit register, I will just get a compiler error. And that's exactly what I want my compiler to do. These types and these values should be guiding my design, and Zig allows me to do that. And I think that because of all these features, Zig has a very strong capability of just being able to represent all of these problems. And I think that Zig has enough power to do all of the things that I needed to do to represent my problems, while simultaneously being simple enough that I don't have to be constantly fighting language. And this is why I really like working with Zig. And just a quick overview of Fun Dude, my actual emulator. I got the CPU working, and the videos working. Interrupts and timers, interrupts that I believe work, and timers are a little bit untested, but these are sort of the core pieces to get anything working. So a lot of different games do run. Mario, as you see, Zelda, Pokemon also runs. So everything it does work, but it's a work in progress. So there's many parts that are missing. Saves are a big problem. Save states, something that I definitely want to support. It doesn't exist. Audio, it's not muted. It just doesn't exist right now. And serial port is something that I really want to start tackling. And this actually will enable online play, which is something that I think might be a killer feature for this. I don't actually know about other emulators, but it'd be nice if we could just be able to play like 2-player Tetris over the internet and have 0 setup. I think that would be an awesome thing. Or like trade Pokemon, that would be pretty amazing. So none of those things work yet. They're all in progress. And I can be found sometimes streaming my progress. I've been doing this for a couple of weeks now, and this emulator's been, I've been working on this emulator for over a year now. So it's definitely a work in progress. And I'm just very happy with how things are turning out with Zig, even though it is a pretty young and pretty unstable language. It has been forcing me to do a lot of things that I wouldn't have even known. So I'm really happy with progress so far. So that is Fun Dude, and that is my experience with Zig. Thank you very much.
Wow. Thank you, Benjamin. That talk was amazing. Thank you very much. I would also doubly recommend to check out twitch.tv/FengB. He's unfortunately is in a time zone that's a bit hard for me to always be able to see to attend live, but especially if you're from the United States, it's gonna be awesome. Thank you again. It's time to move to the Q&A now. So let me let me remind everybody how the Q&A works. So if you have a question for Benjamin, you have 3 ways of letting me know. The first is Twitch chat. Well, let's avoid orders. You have Twitch chat, you have the Zig IRC channel on Freenode, and you have the Zig programming language Discord server in the general channel. In all cases, remember to tag me in your question so that I can see it more easily. And I'm Christoph in all of these 3 places. So yeah, let's switch to the Q&A view. And in the meantime, that people start typing their questions. So Benjamin, let me start with a bit of a default question. Let's say, how did you discover Zig? What's your Zig story?
So I've been my original exposure to Zig is on Hacker News. I saw a quick post. I think it was when Andrew quit his day job from OkCupid, and I've been trying to look for something to replace C for a while. It's not the best language, and it shows. However, I've also been fed up of every other language that I've used, including C++ and Rust even. So when Zig came on the radar, I was like, hey, that's something I should keep in mind. And then when I decided to work on an emulator, I decided to, hey, I think that's a perfect time to try out Zig.
Okay, I see. So we have one question on Twitch. I think you mentioned some reasons why you prefer Zig over C. Are there any others other than the ones that you described earlier?
Yeah. So some of the things I didn't really touch on, compile time, getting rid of macros and using comp time is a big feature. I don't actually do that too often in my emulator, so I wasn't able to really demo it. But there are many areas where we could leverage comp time to design a better. All right, sorry. There are many times where we can leverage comp time to design just better code because we're able to have a much more powerful macro system, or macro is the wrong word, much more powerful meta programming system.
Okay.
Other things are just getting rid of undefined behavior. I think that I sort of glossed over this, but like Zig has much more strict definitions of undefined behavior, and this is not to say that C was wrong. C was actually the reason why undefined behavior existed is because the C spec didn't exist for a while, and by the time they started writing one, they had to rectify all the compiler issues. So there's historical reasons why that happens. Whereas in Zig, it's a lot more well-defined and more explicit. And there are most of the time there are ways around it. Whereas in C, it basically the language just sort of gives up and be like, you're on your own. In Zig, we have things like overflow operator where it forces a certain behavior, or there are like ways to catch the errors and then do it better. Sometimes it's done with the standard library. The standard library is another great thing that I think is awesome in Zig. The fact that Zig supports freestanding makes porting over to WebAssembly amazing. With C, I had to go and find compatible libc in order to like build out something. I had to find a compatible malloc and do all these weird juggles in order to get WebAssembly working. And if that didn't exist solely for WebAssembly, I wouldn't be able to do that. Whereas in Zig, most of the standard library is available on any target, including freestanding. And the thing that was missing was just malloc. And I actually wrote my own memory allocator, which is pretty straightforward in Zig. I shouldn't call it easy, but it definitely, there's a lot of nuances, but it seemed a lot easier to tackle than something like C, where I wouldn't even know where to begin when writing something like malloc. So I think there's a lot of benefits just working with C, with Zig over C. Yeah.
Okay, thank you. There's another question from IRC. So, what's the number one issue in Zig that you would like to see addressed, which would help with FunDude?
Number one issue is probably pack structs. There are many bugs with pack structs, and even though I do know about a lot of them, it still has been a problem when I rediscover them. And it's definitely just a bug, but it's something that I would love to see fixed so that we don't ever encounter that again. The issue is that pack structs don't work if you're crossing byte boundaries or crossing natural word boundaries. So like in WebAssembly, if you have a type that tries to go across 1 byte, it'll be padded in a weird way that the compiler doesn't really like. So you're sort of stuck with doing anything under 1 byte or automatically padded up to like 4 bytes, which can get pretty annoying and tricky, and especially if you don't know that that's happening, which has happened on a few occasions. So that's probably my biggest complaint right now. But again, it is a bug. It's not a design flaw, and it's well known, and a lot of people recommend avoiding pack structs, which I can definitely understand.
Mm-hmm. Let me see. Another question. So, what is the compile to WASM experience in Zig?
Yeah, sure. Let me pull up a code.
Okay, so you want
actually
me?
really easy.
You want me to show the
So,
screen?
am I not showing anything?
Well, it's in a different view. You're right. You don't know
Oh.
this. Let me switch back to the previous view. Yeah. Now we can see your desktop.
Okay. So the biggest thing is that Zig doesn't offer a standard ABI or sorry. Zig by default doesn't have a stable ABI, so I needed to create wrapper functions around everything in order to expose it. So like I needed to do the exports in C. I just sort of did this manually, which would work well, but in Zig it doesn't work. We need a concept of standardizing this, because there are types that don't exist in outside of Zig. For instance, slices don't exist, so I have to convert it into raw pointers. Once I did that, and then it was as easy as going into my build and creating this whole like setting the target as WebAssembly 32 and freestanding. And the other caveat is you have to make sure you're not using any operating system based libraries, which you can accidentally do. Probably the biggest problem is the debug.warn requires standard out, which requires an operating system, which doesn't exist in WebAssembly. And sometimes those error messages can be a little tricky if you don't know what's wrong with that. But other than that, like everything else just works. As long as you're in Zig land, everything just works as Zig, and I don't even have to care about WebAssembly. And it's only this special file that actually does most of the wrapping. So like errors don't cross the boundaries. I have to manually wrap the errors. Everything has to be in pointer because the only types that are available in WebAssembly are int32, int64, float32, and float64. Every other type doesn't exist. So pointers are int32, so that works, and then float64. And you just have to make sure that you're crossing the ABI boundary correctly. And once you're doing that, everything just works, and it works pretty well. And I'm really happy with how everything turned out.
Okay, cool. We have a few more questions. So another one is, how did you pick up Zig so well? So this is from Timmy. I finished the master doc, but I find myself struggling beyond that. Did you read the Zig standard library code?
Yeah. So part of it is that I did come from. I do have a bit of experience with C, and Zig actually maps really well to almost any other low-level language, of which C is one of those. So if you're so that's part of the issue is that a lot of the existing resources online just sort of assume C familiarity. So if you do have C, then you do get a sort of a quick leg up on everything. The other thing, I hang out in IRC. I ask questions a lot, but also like getting familiar with the standard library, reading the code. It's actually very good code. Most of the code is fairly readable and fairly straightforward. They don't require a lot of things, and just getting familiar with how the code is structured there is I think a very powerful thing. And a lot of languages actually offer a similar thing. If you look at some of the Java code or Python standard library, you can probably follow a lot of them. Unfortunately, like C and C++ standard library code can be very hard to follow. So I can definitely understand that if you're hesitant to like open up some of those sources, it can be pretty daunting. But with Zig, I would say that because of the way that the language is structured, it's very regular and very like um, uh, factory-like in a good way. Like a lot of Zig code just looks very similar to each other. When I pull up like code from like say the ZLS, it looks very familiar and it doesn't take a lot of effort for me to read. So that's another strong point of Zig, is that the code tends to follow pretty similar patterns. So once you get pretty familiar with reading like standard library, almost any code can be followed unless it's like designed to be very tricky, which it can be, but like that's more on the programmer than on the language at that point.
Okay. Okay, two questions, and then I think we can move forward. I'm looking for a short answer to have you had any challenges to the fact that Zig is so young and in development?
Yes, and there are many challenges. There are lots of bugs that happen. Many of them, some of them, I would say most of them have either documented behavior or they have an error message saying, "Hey, this is the bug in the Zig compiler." The bigger problems are sort of the hidden bugs that happen. Like, for instance, my pack struck bug, it was just working until it wasn't one day, and I had no idea why, and it took like half an hour to an hour to just figure out the source of it. There are quite a few just compiler bugs. I've created many of them in GitHub issues over the course of my usage of it. Uh, the language iterates very often. So it's been nice since the 0.6 release that the language itself and the standard libraries hasn't changed all that much. But especially with the 0.5 release cycle, we were breaking things like every week. And it can be very hard to follow if you're not aware of these things that are happening. So if you're expecting a language that will stay stable in any way, shape, or form, Zig is not it. If you have the time and the patience to follow it and work through the bugs and to just be patient with the creator. Again, it's mostly a one-man shop. We have many contributors over the language, but Andrew's the only one that's getting paid for this, and he does a great job, but he is still just one person. So it takes a lot of effort for even him to keep up with the PRs and to follow through with things. So for your average person, yeah, we can. It can be pretty tricky to keep up with everything. And there are times where my emulator broke, and it took me a while to hunt down just because the language has iterated. And that'll keep happening at least for the foreseeable future. I have heard that we want to keep it a little bit more stable soonish rather than later. And 0.7, I think, was dubbed a more stability focused release cycle. So maybe we can see a little bit less breaking changes over the tail end of the development cycle before it reaches 1.0. But again, there's no guarantees.
Yeah. And final question. This is from Two Step. Any big lessons learned writing the emulator?
So I don't think there would, like, other than me learning the language and learning low-level programming, I'm not sure that there would be any other big lessons. I think part of it is just that me learning how hardware and emulator works and trying to work around the kinks of synchronizing different pieces. All of those are applicable everywhere. So definitely something that I learned. I've also learned a lot about just bitwise manipulation because Zig offers a lot of great resources for that. And other things, just how to performance tune and try to speed things up. Just basic. I think they would be considered basic low-level programming that I wasn't exposed to before working with writing my own emulator. Because again, I did mostly application level development and all this low level stuff I knew existed. I just didn't really have the time or the effort to learn all of the idiosyncrasies of what to do about like cache misses and branch prediction. But I don't think those are specific to emulator. So I might be the wrong person to ask about specifically what emulation would bring to the table, but I do feel like I learned a lot working on this emulation, and a lot of it is just basic low-level programming.
Okay, awesome. Well, Thank you very much. Don't leave Discord just yet. Stick around for a while longer while I do the outro, because we are now moving to the break.